Alright, so we're given the problem. A car initially traveling at 20 meters per second to the east accelerates to the west at 20 meters per second squared. At the same time that the car starts, a truck 60 meters west of the car and moving 16 meters per second towards the east starts to move faster, accelerating at 1 meter per second squared. It's a one-lane road and both drivers are too busy fiddling with their CD players to notice each other. I'm taking that as they end up crashing into each other. So for the motion information, I put as object event 1, the car is moving, and event 2 is that the cars collide. For object 2, event 1, I put that the truck is moving, and event 2 is that the truck collides. For event 1, or object 1, time 1 is 0 seconds, R1 is 0 meters, and V1 is 20 meters per second east, because velocity shows a direction, and then the acceleration is -2 meters per second squared. For event 2, these are all things that we had to find, and I'll show you how I found them in a second, but I found that the answers were 1.48 seconds, R2 was 33.9 meters, and V2 was 22.9 meters per second. For the truck, or object 2, time 1 was 0 seconds, R1 was 60 meters, which was given, and V1 was 16 meters per second east, because again, velocity shows direction, and acceleration was 1 meter per second squared. T2, which is pretty much going to be the same as the cars, because this is when they collide, is 1.48 seconds. The R2 is 33.9 meters, and V2, which is going to be different than the cars due to the fact that it's going a different velocity and it started at a different area, was 17.6 meters per second. And yeah, so we're going to start down here. So I started out with finding the rate, and I put it in terms of R and T, and kept it so that R, even though we knew what R was and we knew what R was, we had all these from the beginning. I kept them in terms of R and T and just plugged in B, and I plugged in A, and then from there I did substitution, and then I did the quadratic equation. And so you can see my quadratic equation working its way down. And yeah, there's the time where they crashed. There's the car's velocity. You can see quadratic equation working its way down. And then I plugged those answers. See, there's still working its way back down. And I plug the answer that I get from the quadratic equation back into the initial R equations, which were these, and I get all these answers back up top. And so here was the car's second velocity. There's the point where they collide, so which would be the R. There's the truck's second velocity, which you have to do 60 minus the time, or the rate, I'm sorry, you have to do 60 minus the rate because the truck started at a different rate. It didn't start at 0, it started at 60, and then subtract the time, or divide by the time, I'm sorry, not subtract, because velocity is distance or rate divided by time. And yeah, there's time, that is, time. And that is how I got all of my Kinematic. I'm sorry if that's kind of confusing. And then here's my pretty picture. So it shows that the car, so car initially traveling 20 meters per second to the east. Never eat soggy waffles. Okay, so it's initially traveling east and then accelerates to the west. So if it's going east and accelerating to the west, it's slowing down or decelerating. So it's getting slower, as you can kind of tell by the picture. And then the truck is also traveling at the same time. A car starts, a truck traveling 60 meters west of the car starts moving at 16 meters per second toward the east, starts moving faster. So it's accelerating, but it's one lane traffic. So if this one's going faster and this one's going slower, they're going to come and hit at the same time. So that's a pretty graph. And that is my beautiful explanation, and probably very confusing explanation of the kinematics, drawing, and math of the kinematics number 28. So thanks for listening.